This video is going to be about replacing the Icemaker tray in a Whirlpool fridge. This particular one is a 66D22 model, but I think it's actually applicable across a wide range of fridges sold under Whirlpool and its various brands. This is an Australian model, as you can tell from my accent, but I think the same style of Icemaker is used in a number of fairly old models here and in the United States and probably other parts of the world. And this started out because I had a problem with the Icemaker dripping down into the body of the freezer. And although there are a lot of people on the internet who tell you the common reasons for overflowing to occur, those weren't the reasons that my Icemaker was overflowing, and it actually took me a long time to track down the actual reason. Usually it's to do with a leaking water valve. The water valve isn't shutting off properly, and so it continues to trickle a little bit of water into the ice tray until it overfills. I found the problem extremely difficult to track down. In my case, I eventually resorted to turning off the water, filling up the ice tray with a measured amount of water from a jug, and then, much to my amazement, it still managed to overflow, and I was at that point really puzzled, and then I eventually tracked down the problem. This is the Icemaker tray out of this style of Icemaker, and this is where the ice is made in each of these slots here. The way it works is that the fridge measures a small amount of water that comes down into this ramp, flows down across here, fills all of these spaces with water, and then obviously it freezes. And then when it comes time for the ice to be ejected, what happens is that if you look under here, there's actually, believe it or not, a heating element, which is this heat element here. And that heating element turns on briefly to warm the metal, presumably to loosen the hold of the ice on the ice tray, and then a multi-fingered wiper comes down and pushes all of the ice blocks out. On the surface of this is a very shiny, smooth, I presume it's something like a Teflon coating, presumably again designed to allow the ice cubes to slip out relatively easily. And I discovered that what was happening in my old ice tray was that this Teflon coating, just turn this around like this slightly, was flaking off, and there was a small gap between the Teflon coating and the underlying aluminium of the tray, or aluminum as you Americans would say. And what was happening is that the water was actually wicking up behind that loose Teflon and over the edge, and then forming a siphon down the back, and then actually dripping down. What I actually did as a temporary fix was to flake off the Teflon coating from all around here so that there was no wicking path to form a siphon to dribble the water out into the tray underneath. But I also ordered a new tray, which is this one, and I'm going to fit this now. I'll give you the parts numbers in the description down below in case you want to do this fix. So my suggestion is, if you have one of these and it is leaking water down into the tray underneath and it's not the valve, then just check if you've got a flaking coating on here, then water dribbling out here and down into the ice tray might be caused by the coating. Okay, so here's the Icemaker in the top of the fridge, or freezer compartment I should say. Just a couple of preliminary things. You should turn off the water supply to your fridge so that you don't get water coming through it at an inopportune moment. This involves, for me, reaching into a space under the house where I can't even see, and in a place where every third spider will kill you. This is kind of an interesting exercise. And the next thing is turn the power off to the fridge, because there is actually full mains voltage being supplied to the heater and so on in this unit, so you definitely want the power off before you do anything. Okay, so the first thing is this little cover here comes off. You'll see there's around the side of it, there's just a little white plastic plug. If you just get a little screwdriver, you can just point that out, and then the cover just pulls off, if with any luck. There we go. Now this here is the timing knob that controls the inflow of water and the fingers that push the ice out of the way and all of that sort of thing. You don't need to touch that for this repair. But what we do need to do is get all this off so we can get to the screws and so on behind. Now, what you've got to do is undo some screws which are actually down these holes. So you just need a Phillips head screwdriver. Now, you don't need to undo these screws. They actually hold the timing mechanism together, but you can actually take it all off as one unit when you're doing this repair. It's quite stiff to pull out because there's some electrical connectors in there that are quite held on quite well, but you can just pull it backwards and it will come out. The other thing you need to do is unclip this, which is the right here, this wire here. You probably can't see that very well, but this is the bale wire that shows how much, tells it how much ice you've got in the tray. That needs to come out of the back. And you'll also find at this point, this which is just a little cover, and this which is the fingers pushing the ice out will also come out. Just put those to one side. On top of the rotator assembly that you just removed, you'll see there's a white tab here, and you need to push that down so that you can push this connector out, and then this whole unit can just come out. Put that to one side. The next step is to remove the tray. It's held in by 3 screws, one here, and one down underneath here. To remove it, you need a hex head driver. It's a quarter inch size to keep you Americans happy, because you like your old imperial sizes. There you go. So screw those out. One problem you do have, and I'm having it here, is that you really need a short driver, because otherwise it doesn't fit across the fridge. Anyway, it should be all right. I'm trying to hurry through this repair because it's pretty warm here at the moment. It's about 30 degrees Celsius. That's what, 85 in the old scale. So after you've taken out this screw and this screw, and you're doing the last one up here, just a tip: the tray may be full of water or of ice, which is going to cause a mess everywhere. And once you take this last screw out, the tray is going to fall off. So just be ready to support it. The other thing which I forgot to mention right at the beginning was, when you're doing this job, especially if, as I am, you're doing it with a freezer full of food, just get a cloth or a towel and put it over everything down there, so that when you drop a screw, which is going to happen, it doesn't find its way down in the food and you spend 20 minutes looking for it. Right, so just the hard thing about this job is trying to get 2 hands in the job at once, but I'm trying to hold the tray up with one finger and undo with the other. There we go, and then it all comes out. So here's the old tray. As you can see, it's a complete mess. And if you look down in here, you can possibly see, I'm not sure you picked it up on the camera, but you can see the coating is all sort of wrinkled and coming off. And if you look down in here particularly, you can see where the old material has been flaking off. And this is where it was actually siphoning. The water was coming up behind the coating up here, and then siphoning down and down into the water tray. Now I'm going to remove the working parts from this old tray and put them on the new one. This little white clip at the end, the trick is to just push it inwards and it comes off. Turning it over, there's this tray which covers up the heating element, and if you just once again take your 1/4 inch hex head driver, of that. Remove these wires, get rid of that. So here's our new one, and we just have to put the fittings back onto it. First step, turn it over and turn it around, put the shield back on. It's actually slightly easier to put this wire in before you put the shield back on. You can do it afterwards, but it's just a tiny bit more awkward. The end, it's different on either end. One end's got pins, that end goes down here, the end with the rounded part of the heavy heating element, and this end has kind of got little contacts there, and that goes down this end with the pins here. So if you just put that, just tuck it inside that fold in the aluminium heat shield, then put it on like that, and now taking your quarter driver, quite stiff I suppose because it's new, and the other end. Don't put anything in this hole here because that's also used to hold it into the freezer, so you've got to leave that one until it's actually, you're putting it back in the freezer. And then turn it over, this plastic fitting needs to go in. Probably the most difficult part of this whole job is that you've got to get that electrical connector onto a connector down here, and you don't have much to push against, and if you push too hard you actually end up pushing that connector back into its housing, and then it's very hard to retrieve. At the same time, what you don't want to happen is you don't want this cable to get pulled out of its housing here, because then it's difficult to get it back in. But anyway, I'll give it a go. Now, I'm not actually going to show you this process because, well, firstly I can't, because I need to reach in with both hands to do this, and I can't do that and get the camera in, and you wouldn't see anything anyway, but you just have to struggle with it to get that connector on down the end. I've got the connector on now. It's just hanging by those cords at the moment. And what I now need to do is put the screws in without the connector falling out. Okay, now I've got both of those top screws in. I'm just going to tighten them up. And now I'm putting the final screw in underneath. The next step is to get the power connector back into this module, and it's quite tricky because it's got to go back down into this corner, which is the bottom left corner down here, and it's difficult because you don't really have much to push against. Don't be tempted to pull the connector, because if you do, it can come out at the back, and then you've got to take the whole thing out again and start again. So, but you just got to do it while holding it up as best you can, and it should click in. There it goes. Next, you've got to put in this wiper arm. It's got axle or pins which go on each end. One is fatter and one is thinner. The thin end goes up the back into that hole that you can see and just sits there for the moment. The next thing is this cover. You'll see that at one end there's one big fat tab, and that goes on in a little slot down the back. It's fairly easy to see, and then it clips in at the front like that. And now the main module goes on, and you'll see that there are some two spikes. Those are for the power to the heating element, and there's a spike here which I think is something to do with temperature, and they've got to go into corresponding holes in the back of the unit. So you just fiddle it in. You may find that you need to rotate the paddle around a bit to get it to go into the right spot before it clicks in. There it goes, it slides on. The last step is to get your bail, this wire here, and it goes in a hole at the back which corresponds to this white hole at the front. It will only go in one position. There it is. That's back in. Right, that's all back together. And now we just need to screw through these holes, screw the captive screws back into position. Now it's simply a matter of getting this cover. The hole goes in the lower right-hand side. Pop the clip in, there we go, and that's now done. Let's turn the fridge back on and turn the water back on. And if I don't post this video, it's because I've been killed by a poisonous spider turning the water back on. If you found the video useful, I'd appreciate it if you could possibly hit the like button down below, and see you next time.